Your resonance circuit is, capacitor is your potato, but your another part, the spring, is just your phones. So you don't demodulate the signal. You just use the modulate signal. You need to demodulate the signal to hear some noise. So first of all, we was choosing the type of the radio we want. So and left circuit, it don't work. It don't demodulate the signal, and you couldn't hear what you want. The right tab is FM radio, and it's very complicated. I'm too stupid to understand it, so I choose AM radio. What does AM receiver do? So this is resonance circuit. The capacitor was a potato, and if you use like 1 megahertz signal, your antenna should be at least quarter of wavelength, and it's 160 meters. And the antenna does not help you. Nobody, I think, have 160 meter antenna, and the antennas that you use simply don't help you. Then you have diode, like the green circle. It just splits the positive signal. Then you have integrator that make it into the sinusoid, and then you have differentiators that shift the baseline, and now you have a signal. So this is our setup. So we have a potato, we have a coil for resonance. There was diode, there was 2 capacitors, and oscilloscope and signal generator. Why do we use a signal generator? You can, so why does we switch from AM radio to FM radio? Because AM radio depends of the amplitude of your signal, and while you are in a city, there are plenty of metal things that make your signal bad, and it's very hard to catch in city the signal from AM radio. So we made our own broadcast center. How to play video? I click it. No. Okay. Yeah, I'm trying. So what do we see? I have IM modulated signal on my, there's just electrode line nearby, and it was working like a radio. So I have IM modulated signal, and my potato was demodulating this signal. And I have the clear signal when I was changing the modulation frequency. I have the same sound from my potato. And you can see it on the frequency diagram of sound from my cell phone. And it was working pretty well. So when we already have our radio working, so the question is try to use another apples, oranges, and other stuff. So our pickup was potato, cucumber, carrot, apple, lemon, orange, and tomato. There we have different surfaces of the cut, different resistance of the 1 centimeter, if I put electrodes 2 centimeters wide, etc., etc. But there was really similar. So on the first glance, I see no difference of these fruits and vegetables, and I was assuming that they all will be working. So the capacity was just simply dependent on the surface of the cut, and knowing their their capacity and their inductance of my coil, I just simply calculate the frequency resonance what I was expecting. But I see that for potato and carrot it was working. For lemon, orange, apple, and cucumber it wasn't working. And for tomato it was working on the absolutely different frequency. 13 megahertz instead of some parts of kilohertz. And at this point I have the very good questions why. And the answer surprised me. So the problem is they are not real capacitors. And their capacity depends on the frequency of the signal. And for potato and carrot, the capacity grows with the frequency. So for carrot, how do you measure the capacity? Mostly, you just take your multimeter, put 2 electrodes, and it measures your capacity. But your multimeter measures capacity on the frequency of 10 kilohertz. But you can measure it on other frequencies. And if you measure carrot capacity on 500 kilohertz, it will be not 0.48 nanofarad, but 0.52 nanofarad. And for frequency on 1 megahertz, it's 0.79 nanofarads. For the lemon, it's falling. For every thing that have electrolyte in it, the capacity was falling. What does it mean? If we take calculation for resonant frequency, it depends on the capacity. And if we, if capacity is growing, the resonant frequency is going down. But if it's dropping, it's going up. So it's just escaping from our resonant frequency. I don't know why. The question I have to ask. So only was working a tomato because its initial capacity was very low, and we were able to catch it up while we get out of limit from our signal generator. Yeah, okay. So, okay. So this is if we have signal generator, we can have a response function for every frequency of the signal we have. And we see that our radio was working on the frequency from 200 to 10,000 kilohertz, 10,000 hertz. And it was pretty enough, but left one is for carrot, right one for the potato. So I also have the carrot was working the best. What about sound fidelity? So this is changing of the time of the frequency. So on the down we have frequency, on the left we have signal volume. So we see 4 lines, and their color describes their loud, how loud are they in decibels. And we see that we have not the initial frequency that we are receiving from signal generator, but also the 4 smaller frequency. And for potatoes, difference was 4 decibels, and for current 5 decibels. So if we have some frequency, we have additional frequencies that goes in a row, by coefficient multiply. And for carrot, the difference was 5 decibels, so fidelity of the sound will be better. Carrot transmitter. So on the left you see the scheme, and they used denistor. So this is simply a scheme that could be used to have a potato make a sound. And actually, it was also working. But, for example, really bad. Because this scheme is too simple to make it work. So we use our signal generator now as a speaker. It just stays sinusoidal with 10 or 5 or 6 kilohertz. As you can see, the fidelity of sound is not very good, but still it works. So, and for the conclusions, I was very surprised that capacity could change with the frequency. These facts, I haven't heard of elements that behave like this before. And for me, it's still a question, why does it happen? But anyway, it was measured, it's a fact, and this is why some fruits can be used as radio, and some plants don't. Thank you.